this video on systems of inequalities word problems. By the end of this video, you should be able to read real-world scenarios, construct a system of inequalities. You should be able to solve real-world systems of inequalities, and you should be able to graph the system of real-world inequalities on a coordinate plane to determine the solution area. Alright, so what we're going to do is we're going to write equations like we have, inequalities like we have done in the past, but then we're going to have to convert them into slope-intercept form in order for us to be able to graph them easily. And then we're going to come up with two possible solutions that could work, because there'll be many. Anything in the shaded region is a solution. Okay, so suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. Okay, so we got a couple things going on here. We're trying to make two equations. So let's define some variables. We have X and Y. And so we're going to buy flour and cornmeal. So flour is mentioned first. I'm just going to make him X, and my Y will be my cornmeal. So I'm going to label over here flour and cornmeal. Okay. Now let's go with our inequalities. We have that flour costs $1.50 per pound and cornmeal costs $2.50 per pound, and you want to spend less than $25. That's your equation. So it's $1.50 for flour plus $2.50 for cornmeal. And when I spend all of that money, it has to be less than or equal to $25 because that's all I've got. Okay, now the second one, that's usually the harder one to write. You got to think about it. We want at least 6 pounds. So we want at least, which is greater than or equal to 6 pounds. Well, where does that 6 pounds come from? It's from the weight, from the amount of flour and the amount of cornmeal. So flour plus cornmeal needs to weigh at least 6 pounds. Okay, so this is where we took these and put these in matrices and solved them, or we could use elimination. But we're going to graph these on the real world plane. So remember, your real world will be your first coordinate, your first quadrant. So we're not going to be over in the other three at all. So anytime we're doing our shading, we're going to stop in our first quadrant. But we want to write these in slope-intercept form to make them easier to graph. So the second one here, this one's going to be a little easier. We want to get Y alone. So let's subtract X from both sides. And so this in slope-intercept form is Y is greater than or equal to negative X plus 6. Because you want to put your X value first because you have your slope here in front. So your slope is really negative 1. So we're going to start at the Y-intercept of 6. 1, 2, 3, 4, 5, 6. And you have a slope of negative 1, right 1. Okay. This is going to be a solid line. So I'll draw a solid line. And I know that it's going to be greater than or equal to. So from the Y-intercept, greater than is above. So that's going to be all this. Okay, so anything in this pink area will solve the real world situation that we're talking about. And it goes on forever and ever and ever. This is just what we're looking at in our little snapshot. So now let's work on the other inequality. I want to move the X to the other side. So I'm going to subtract 1.5X from both sides. So I have 2.5y is less than or equal to negative 1.5x plus 25. Okay, there's decimals, but it's okay. We have calculators. It's money. Decimals happen all the time. We're going to divide by 2.5 to get the y by itself. Okay, and I'm going to get y is less than or equal to 1.5 divided by 2.5, so we'd have to come up with a number. So let's think about this a second. So we need to come up with our fraction there. And 25 divided by 2.5, if you do this with your calculator, you will get 10. So let me look. If I take with my calculator negative 1.5, negative 1.5 divided by 2.5, and I got negative 0.6. I can tell mine to turn it back into a fraction. So let's see. So I go math, fraction, and not all the calculators will do that. That says it's negative 3/5. So that says start where y is 10, go down 3, right 5. So we know that this is 6, 7, 8, 9, 10, down 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5. This is also a solid line. So I'm just going to connect all of my dots together. And now I have to look at my shading. So my shading says the y is less than. So from that y-intercept, less than is below the line. So I'm going to start all the way across with the line. Don't go below the x-axis because we don't exist down there. All right. So the purple area, this is what will work for us. Any combination of flour and cornmeal in the purple area will answer the question. So that's what we're asking in part B. What are a couple possible solutions? So I don't know, let's see. 1, 2, 3, 4, 5, 6 pounds of flour and 2 pounds of cornmeal would work. That's right there in the purple. So I'd say 6 pounds flour, 2 pounds cornmeal. So notice I'm putting the answer in the context of the problem instead of just writing 6, 2 as the solution. What it means specifically to this problem is 6 pounds of flour, 2 pounds of cornmeal. Any number in here, we could have 1 pound of flour to 7 pounds of cornmeal. 1 pound of flour is 7 pounds of cornmeal. Okay, you could pick any coordinate pair in the purple shaded area to answer your question. All right, let's try it again, see how we're doing. A seafood restaurant owner orders perch and salmon. Those are two different kinds of fish. Perch is $4 a pound and salmon is $3 a pound. He wants to buy at least 50 pounds of fish but cannot spend more than $240. So he doesn't want to spend more money than he's got. So let's see what we can write here. So we know we have perch and salmon. Perch is mentioned first, so I almost always make the first one the X so I don't get confused. So X is perch, Y is salmon. We have something about money here. Look, money, money, and monies. So that's an equation. So it's $4 times the number of pounds of perch plus $3 times the number of pounds of salmon, and he cannot spend more than $240. He can spend $240, so it's equal to, that's fine. Okay, so that's the one equation. Then we got to talk about the other equation. We know that he wants at least 50 pounds. At least means greater than or equal to 50 pounds. So however many pounds of perch plus however many pounds of salmon, and they need to be at least 50 pounds. All right. So from here, we've got our inequalities. We just need to put them in slope-intercept form so it's easier to graph. So I'm going to subtract on the bottom equation. He's a little easier. I'm going to subtract x, and this equation will be, our inequality be, y will be greater than or equal to negative x plus 50. So that makes me start thinking 50 as a y-intercept. I'm probably going to have to scale my y-axis somehow. And then let's go ahead and take care of our top inequality. I'm going to subtract 4x from both sides. And that will give me 3y is less than or equal to negative 4x plus 240. Divide each thing by 3. And y is less than or equal to negative 4 over 3x plus 240 divided by 3 is going to be 80. So what that's going to tell me is I'm going to count by tens up here on my y's. So I'm going to label this. Remember, x is perch, so this is the pounds of perch. Y is salmon, this is the pounds of salmon. And so this is going to be 10, 20, 30, 40, 50. Each one's going to count by tens for the y's, but the x's we can just count by ones. And we'll be okay there, I think. So let's start. We're going to start where y-intercept is 50. So 10, 20, 30, 40, 50. And a slope is negative 1. Okay. We said greater than or equal to, so that makes that a solid line. If you're still having trouble figuring out where to shade, put your pencil or pen on the y-intercept where the y value is greater than that point. That would be up, which is going to be this whole side over here. So I'm going to shade that. I'm going to follow the line. I'm going to stay in the first quadrant because this is real world. So all of this works for the bottom equation. Okay, so let's see what happens with the top equation. So we need to start where y is 80, so that's 50, 60, 70, 80. And this says go down 4, right 3, down 4, right 3. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, oh, it's pretty close to the other one. It is also equal to, so I'm going to just connect my points to make it easy. And the other equation says the y's are going to be less than this line. So I'm going to go to that y-intercept. Less than is below the line. So that means I'm going to shade right here. So I've got this skinny little solution set right here between the two lines. It's purple. So anything between the two lines will work. So let's come out with some solutions. So I've marked 2 points here for us to see. And so we're really counting these by 10 pounds each way. So this would be 10, 20, 30 pounds going on the perch direction. And then we had to go up 10, 20, 30 pounds of salmon. That's where we can split it. We got exactly the same amount of each, and that spent all of our money. Or here's the other one. It's only 1 to the right for perch, so that'd be 10 pounds of perch. But then I'm 10, 20, 30, 40, 50 pounds of salmon. All right, hopefully you're kind of starting to get the hang of this. Let's try this again. So we have CDs. So back in the day, we used to listen to music on CDs. You guys stream it all now, but so the We Sell CDs website plans to purchase ads in a local newspaper to advertise their site. Their operating budget will allow them to spend at most $3,000. So at most means less than or equal to on this advertising adventure. An ad will cost $30 to appear on the weekday paper and $50 to appear on the weekend edition. They plan to run at least 20 ads. At least is greater than or equal to. So what are we talking about here? That's what we got to get started with to help you with this. We're talking about kinds of ads. So they have weekday and weekend. So I'm going to say the day is X and the weekend is Y. Just to kind of help us think about this. So at most $3,000. Less than or equal to $3,000. Well, when you're talking about money, the equation, the inequality that comes before it has to do with money. So we have $30 for weekday, so that's $30 for weekday, and $50 for weekend. Okay, money, money, money. So we're good there. So now let's go with our other inequality. They need to run at least 20 ads. So at least 20 ads. Well, those ads are being made up of weekday and weekend ads. Okay, so let's graph to see what will happen. We need to put in slope-intercept form, so I'm going to move the x over. Minus 30x, so I get 50y is less than or equal to negative 30x plus 3,000. Divide everything by 50 to get y by itself. So y is less than or equal to negative 3 over 5x plus 60. Okay, so that's one of our inequalities. The other one's a little easier to get. We'll just subtract the x from both sides, and y is greater than or equal to negative x plus 20. Okay, so we're going to run the same like we did with our salmon and perch. We're going to run in 10 increments. And so our x value was our weekday. Our y value is our weekend. Labeling them makes it a lot easier to kind of get your answer. So I'm going to start with this inequality that starts at 20, so 10, 20, a slope of negative 1. Okay. It needs to be solid. And the y value is greater than or equal to. So go to that y-intercept, greater than or equal to is above. So I'm going to shade all of this for that bottom inequality that we wrote. All right. Once we have that, let's go and graph the other inequality. Always graph only one of them at a time. Don't try to do them both. You're going to get yourself confused. So 60 says 10, 20, 30, 40, 50, 60. Down 1, 2, 3, right 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. We run out of space because now that's all we have for the real world. It's equal to. So I'll connect it with a line. And it says the y is less than. So go to that y-intercept. Less than is below. So I'm going to shade this region. So anything in that region will work. The only thing that won't work is right this little teeny tiny section here and this pink section. So anything in the purple section works. So for example, this one would be 10, 20, 30 weekdays and 20 weekends. So 30 weekday and 20 weekend ads. I could pick any point. What if I wanted to pick that one right there? So that is 10, 20, 30, 40, 50, 60, 70, 80 weekday ads. But I only went up one, so that's 10 weekend ads. All right, let's flip this over and try another one on the back. All right, for our last one, let's try problem number 6. You'd like to see how many baseball and soccer games you can attend this spring. Travel times for baseball games is 2 hours and soccer games is 1 hour. You would like to spend no more than 15 hours traveling in the games. In total, you would like to attend at least games. So a couple things I see right off. You would like to spend no more than, so that's less than or equal to, 15 hours traveling. So we know we'll have no more than 15 hours traveling. And then we want to attend at least 8 games. So we want to attend at least 8 games. Okay, so this 15 is hours traveling. That means anything that has to do with hours traveling goes into this inequality. So, oh, we didn't define any variables. Let's do that. So we had baseball came first. So I'm going to say X is baseball and Y is soccer. Okay, so we have travel time for baseball games is 2 hours. So 2 hours for baseball, plus 1 hour for soccer, and I don't want it to be more than 15 hours. For my other equation, I want to go to at least 8 games, and the kind of games I'm going to is soccer, baseball, and soccer. I put an S, that needs to be a Y. Okay, just like we've been doing, let's graph these. So I'm going to subtract X here. And we have Y is greater than or equal to negative X plus 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. And it's a -1 slope that looks like this. It is an equal to, so we have a solid line. So we'll just connect all of these together. For our other inequality, let's subtract the 2x from both sides. So you have Y is less than or equal to negative 2x plus 15. So that's 8, 9, 10, 11, 12, 13, 14, 15 with a slope of negative 2 over 1. So down 2, right 1, down 2, right 1. And just keep doing that. Okay, that's also solid. Oh, and I just broke my rule. I graphed both lines and I didn't shade. So what if you do that on accident? So here's what we're going to do. I'm going to go to this inequality. It's got the y-intercept of 8. So that's right there. It says the y's are greater than. So they're greater than this line. So I'm remembering I need to shade completely above this line. Doesn't matter that the other line is there. All of this needs to be shaded. Okay, I followed the whole line, so I'm good there. All right, now for our other inequality, it says the y's are less than the line. So here's your y-intercept for that line. And less than would be down here. So I'm going to follow the line first. And then I'm going to go and get the rest of my region. Okay. So what we're looking at that we can do occurs in this purple area. So let's see what kind of questions we've got here. Suppose we decide on attending 4 baseball games. What is the range of soccer games that we can attend? So if we have 4 baseball games, so remember this is baseball, because that's our X value, and our Y value is soccer. 4 baseball games, 1, 2, 3, 4. So to have 4 baseball games, how many soccer games can I attend? I can attend this one, and this one. Well, what are those? This is 1, 2, 3, 4. So I can attend 4 games, 5 games, 6 games, or 7 games. So I can attend 4 to 7 games. But we're going to write this as the range. So 4 is less than or equal to Y, which is less than or equal to 7. So this is saying, because Y is soccer, I can attend anywhere from 4 to 7 games if I want 4 baseball games. Now, suppose we decide on attending 9 soccer games. What's the range of baseball games we can attend? So this is 9 soccer games. So 9 soccer games is here. If I want to have 9 soccer games, I can attend 0 baseball games, 1 baseball game, 2 baseball games, or 3 baseball games. Those are the only ones that end up in the purple. Okay, so here I want to know how many baseball games I can talk to. Baseball is the X value. I can go from anywhere from 0 baseball games to 3 baseball games. All right, one last question. Is it possible to attend 6 baseball games and 4 soccer games? So really, you're saying, is the 6.6, 4 in the purple region? 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, look at that. It's just outside. You see, it's just barely outside. No, it's not possible. It's outside the shaded, double shaded region. Okay, hopefully that was helpful to you. Let me know if you have any questions, and I will see you in class.